In a pumping station, several situations may generate energy losses and significant extra costs, in particular when the operating range of pump flow rate, TDH, greatly varies. Pumps have been oversized, thereby preventing them from functioning at their maximum efficiency range. These situations may occur when demand by customers greatly increases or decreases on an hourly, daily, seasonal, or annual basis. It is therefore possible to adjust to these demands and optimize energy consumption by installing variable frequency drive, which allows the operations of a pumping station to be regulated electronically. We are going to discuss how variable frequency drives work, then focus on the conditions in which they're used and their limits of use. A variable frequency drive is an electronic piece of equipment that transforms and regulates the electricity that supplies the pump's motor on the basis of a fixed or variable set point over time. It receives from the electricity grid a current of 50 or 60 Hz, depending on the country, and transmits a current to the motor at a frequency which varies. In Pakistan, this frequency is 50 Hz. It allows the rotor's rotational velocity to be changed. A pump's flow rate is proportional to the rotational velocity. The pressure is proportional to the squared rotational velocity, and the power required is proportional to the cubed rotational velocity. A variation in velocity causes the pumping station's flow rate and discharge pressure to vary in order to adapt to the change over time in the network's water demand. Consequently, it also causes the power required by the facility to vary. Concretely, as the following diagram illustrates, using a variable frequency drive results in a pump's duty point moving along the network curve. The pump's curve is modified by the variation in velocity. For each rotational velocity, an equivalent flow rate TDH curve can be reconstituted using the initial curve supplied by the pump's manufacturer for a nominal frequency of 50 Hz or 60 Hz. Generally, a pumping station is fitted with several pumps working in parallel. Using a variable frequency drive on each pump provides for greater flexibility regarding the duty points, and therefore the discharge flow rate ranges, as can be seen in the following diagram. Let us now look at a few points that require attention if we wish to install a variable frequency drive in order to regulate a pump's operation. First of all, the variation in velocity can only occur in an interval of around plus or minus 20% of the nominal velocity. Furthermore, as previously stated, the power required proportionally increases to the cubed velocity. So a slight increase in velocity causes a significant increase in power. Therefore, it is necessary to ensure that the motor is not overloaded when the velocity increases. It is essential to take into account the shape of the network's curve and the duty point before installing this equipment. Indeed, as we can see on the following diagram, in the R1 network's curve, the duty point fluctuates in the zones where efficiency is excellent. Curve R1 corresponds to a network with significant head loss and low total dynamic heads. On the contrary, we can see in the curve in network R2 that the use of a variable frequency drive lowers the yield, which demonstrates that installing a variable frequency drive is not always relevant from an energy efficiency point of view. Therefore, a detailed technico-economic study must be systematically performed to find out if the variable frequency drive will enable the pumping station to be optimized in hydraulic and energy terms. Varying the velocity is not the only solution. It is necessary to check that the overall savings in electricity is indeed higher than the variable frequency drive's electricity consumption, and the possible decrease in the power pumping unit's overall efficiency. For this to occur, it is therefore important to accurately know the network's curve, The fluctuation in the duty point or operating range, according to rotational velocity, and the effects of this on a pump's efficiency and power. Electricity costs, hydraulic constraints and operating methods required by pumping stations to potentially install a variable frequency drive. What you need to remember. Fitting a variable frequency drive enables the duty point or operating range of pumps to be regulated with the help of an electronic device in order to optimize a pumping station's energy consumption. The technico-economic relevancy of fitting a variable frequency drive must always be studied in order to check that it enables pumping to a network located downstream to the station to be optimized in terms of water and energy.